Hello, guys. Welcome back to this experiment to demonstrate the effect of albedo on temperature. So, this albedo is actually it is some quantity of light reflected by a body is called as a albedo. As you know, the different bodies have the different reflectivity because of their colors. Generally, the black bodies absorb more, reflect less, and the white bodies generally reflect more and absorb less. It's all this is called as the albedo. So this we are going to prove here in this a very small experiment. So this is in this experiment we are going to demonstrate the fact that light colored objects tend to have a higher albedo, while the darker colored objects have a lower albedo. So the apparatus required are you need two thermometers of the same kind for better results, and you need a black colored paper packet. So a rectangular packet is made with the help of a black colored sheet of paper. So that is called a black colored paper packet. We have to make two rectangular packets of the same dimension, and one is made with a black colored sheet of paper, while the other is done with white colored sheet of paper. So that kind of two sheets of two packets you need, and the two table lamps are needed, and incandescent bulbs. You need two bulbs for the table lamps, and one stop clock is required. So these are the two, some of the simple things which are needed to demonstrate this experiment. The albedo of an object is a measure of how strongly it reflects light from a light source, such as the sun. Albedo is the, as I told, albedo is the percentage of incoming light that is reflected rather than the absorbed. So it is thought that Earth's average albedo is 30%. That means 30% of light incident on the Earth's surface is absorbed, whereas the remaining 70% of the light is reflected from the Earth's surface. So energy in the form of visible light from the sun warms the Earth, as you know, and some of the energy from the sun is reflected back into the space, while some of the energy is absorbed. And the things like clouds, snow, ice, land, and particles or pollutants present in the atmosphere can also reflect the energy back into the space. So this part is absorbed by the earth, which warms the surface, which then re-radiates the infrared, which re-radiates the energy in the form of infrared radiations back into the space. That means once the earth becomes so hot, it starts re-radiating the radiations into the atmosphere. Those re-radiated radiations are generally in the infrared region, so that is why they are called as the thermal radiations emitted back by the earth. So what happens, the hotter the earth surface, the more energy is radiated out. This is quite obvious. So here we are showing the meaning of albedo. So low albedo, because the surface is darker. The surface is darker or having darker colors. So you can see here some 10% of the light is reflected. So we say that this is the case of low albedo. That means this is the surface with low reflectivity. And you can see here 80% of light is reflected. So you can see here Generally, these are the white surfaces or the surfaces colored with the white color or something light colors. So in such cases, the reflectivity will be high. So that shows that the albedo is also high. And thus, so in general, light colored objects tend to have the higher albedo, while darker colored objects will want to have the lower albedo values. So it's all I have explained in case of Earth. What are the things present on the Earth also matters, like muddy surfaces, stone surfaces, where the absorptivity of the incident light or the sunrise is more, reflectivity is less. So they are the surfaces of low albedo, and hence they become more warmer than the other surfaces. So, and greenhouse effect is also affects sometimes here, because generally when the earth gets warmed, it re-radiates the energy into the space, and that re-radiated radiation emitted by the earth in turn falls on the whatever the what is that various gas molecules or atoms present in the atmosphere. They absorb the energy and they become warmer. So that leads to slightly rise of temperature, that and that we are calling as the greenhouse effect. So greenhouse effect is also come into picture here, as it is related to the radiation emitted by the earth. And even some examples like snow temperature feedback or the conversion of a snow covered area. Suppose that initially some area, especially in Western countries, sometimes in winter season, what happens? The whole surfaces are covered with the snow. So, but when the snow is over the Earth's surface, the reflectivity of the radiation is actually high. So that means this snow covered area is having higher albedo values. But as the time passes, the snow starts to melt, and the remaining earth surface start to absorb the more radiations, and hence having the low albedo values. So this kind of natural cycles are taking place on the earth, as you know. So this is the general statement of what I have done. So now we will come to the experimental procedure, what you have to do in this experiment. So the first step is to place the two thermometers, preferably of same scale and range, are inserted, one into black colored paper packet and another into white colored paper packet. So you'll be having two paper packets. One is made of black color and other one is made of white color. So into those paper packets, you have to insert these two thermometers and keep the two paper packets such that longer sides of the packets are parallel and in contact with each other, so that they are very close to each other. And the two thermometer ends should be towards your side, so that you can see the readings easily over the thermometers. Make sure that the mercury levels are seen on both the thermometers which are inserted into the paper packets. That means when you insert the thermometers, you should take care that the mercury levels are up, so that you can see them very easily. And note down the room temperature readings on both the thermometers. And now keep the two table lamps very close to each other, so that the light of these two table lamps exactly fall over the two packets. And now switch on the both the table lamps and the clock simultaneously. Now you have to switch on the lights of table lamps, and at the same time you have to switch on the clock so that timing is counted. Note down the temperature on both the thermometers at every 1 minute of time lapse up to 15 minutes. And plot a graph of time versus temperature and observe the result. So this is the arrangement what we have to do. So this is a black colored paper packet in which you have inserted a thermometer, and this is a black white colored paper packet in which you have inserted the same kind of a thermometer, and this is one table lamp and this is another table lamp. You have the two table lamps, and when you switch on these two table lamps, the light from these two table lamp falls on these two packets. The purpose of using two table lamps is to increase the intensity of the incident light. So that is the purpose. So your table can be like this: observation table, serial number, and here one column is required for the note down of time. And in this column, you will note down the temperature of the black colored body, and here you will note down the temperature of the white color body. So what you will observe is that the temperature of the white color body will be increasing speedily, whereas the temperature of the white color body will be increasing slowly. So this observation will be seen, and you have to plot a graph, of temperature versus time like this, and this kind of curves you will get. So here I have shown these two as a straight lines, but what we have checked is that they are not exactly the straight lines, they are curves. Slightly they are curved lines, and they become flat in upper side, and this is also become flat at the higher time rates. So they are not exactly the straight lines. So you can see from this graph that the temperature of the black colored body is more, whereas the temperature of the white color body is less. So this is because of albedo. Because the albedo of the white color body is more. The albedo of the white color body is more means that body will reflect more and absorb less. In the same way, the 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 albedo of the black colored body is less. That means the reflectivity is less, and hence the black color bodies absorbs the more thermal power, more radiation, so that their temperature rises fastly. So this is a very simple experiment we can show like this. So this is the case of low albedo, and this is the case of a high albedo. And I will show you here the experimental just a minute. So I am showing here the experimental arrangement, what we have done for this experiment. So, this is a black colored paper, simple, very simple. Take a sheet of a black color paper and fold it like that and staple it. So this is white color, and similarly you make another packet of made of white sheet of paper, and just staple them, and you can staple here also. and you have to keep some opening here to insert the thermometer. This is the thermometer 1, this is the thermometer 2. Actually, as I told, we should use the two thermometers of the same type, but in our lab, same type were not available. So that's why I used a different kind of thermometers, but no problem, we can see easily. So these are the two uh, table lamps having the incandescent bulbs. Both are switched on. So high intensity light and uniform intensity light is falling over these two packets in this way. So this is also you can see here clearly. So this is one thermometer, another thermometer. Mercury level also you can see here. Mercury levels is somewhere here, and for this it is somewhere here. That's why if you are using two thermometers of the same type, it will be more useful, or easy to compare. No problem, but you can do the experiment. So this is the experiment to demonstrate that that the bodies of low albedo like this will have the what is that, less reflectivity, whereas this kind of bodies, white bodies, have the high reflectivity. High reflectivity means high albedo. Low reflectivity means low albedo. So this is the experiment demonstrated. Thanks for listening.